Hello everyone and welcome back. So let's implement this pop-up, and we have that set up. Okay, so point cloud open, and we want the third input. The channel is P, and I'm gonna set this to 250, and we're gonna filter, and we want to filter the point position, subtract this from this, normalize it, and then we're going to use a length node to compute the distance. Fit range that and change it from 1 to 0, and this will go with 4. We can plug it into the color so we can see it every frame, and we're going to use this as a multiplier, and this should attract the points or push them outward. We will know soon, and we're going to use this on top of the velocity, so we're going to keep adding it to the velocity for now. Okay, so they're pushing, it's pushing outward, so we're gonna swap this, and instead of adding it to the velocity, what we can do is we can plug it into force, and this is gonna do something similar to what we did in the previous node. I just wanted to show how we could do it if we wanted to go all the way with customization, but we can plug things into the force, and it's not going to be it's not going to be accumulating over time and exploding the velocity. So I put down a multiplier in case I wanted to tweak this, and let's make sure we connect this. And I think the distance is too big, so let's try 2. Let's try 1. Let's try less, 0.5. Okay. Hit play, and I think it's doing something. Yep. Sorry, it's not doing anything. We have this set to 0. Let's hit play, and it looks like it's working. Let's set this to 10, and you can see already, you can see the curves in these flows. And that's what we want. So the points are getting attracted to the nearest point, the nearest curves, and with a force of 10. So we'll keep that. And the other thing we need is the cross product. So I'm gonna put down a cross product, and we're going to add or mix both of them. So we're gonna mix the one that pushes inward with the cross product, and all of that gets multiplied by this, and then all of this gets multiplied by our control here. And there it is. And if we hit play, if we preview the velocity, we're going to see the points swirling around. I think right now they're not swirling that much, so let's just preview this. Let's not use the one that pushes inward, and see how they're going to rotate. Yeah, you see the rotation they're going, but it's not too strong. So we'll multiply the rotation by 2 here. And let's make sure we cross product the normalized one. And let's connect it. And you see it's here, it's quite strong. So go back to 1. I think the normalization helped. Yep. They should have been normalized. And let's mix both of these. So what I want is I'm going to use 75% of the one pushing, the one swirling the points, and only 25% of the one pushing the points inward. And let's hit play again. And I think it's working. Yeah, we're getting some nice rotation, and they're attracting to the curves as well. I think so let's see. I'm gonna invert this. I'm gonna negate it. And I'm gonna put 50% of each. Yeah, I'm gonna try 0.25. I want them to clearly show that they are getting attracted to the curve, so I'm using more of that force. Okay, so what we can do is we can go up and let's put down the result is here. So let's simply trail this, and this will allow us to view the result better. And you see they're doing this cool swirly thing around the curve. Okay, so I think it's all working. I'm just gonna multiply this a bit. Which one? This one. I'll multiply the attraction to the center a bit more, and then I'm gonna increase the fit range to 1 and 2. And I don't want this to be 0. I want the point to always be affected by the system, no matter how far they are. And I'm going to turn back on the attraction we did and turn off this because we don't need it at this point. And if we hit play now, it's going to look very, very interesting. Yeah, you see they get sucked in onto the very close to these curves. So we just have to tweak the force a bit, but it's working. Yep. Okay, let's go up and let's visualize this without the trails. You see this is doing something really cool. But they're all flowing this because that's how the velocity is pushing them. And when they get close to this, they're gonna do that tornado. It's really cool. Okay, so the next or the last thing that we can introduce is a little bit of noise here. So instead of doing a perfect lookup, or after we do the lookup, what we can do is we can add a bit of noise to this. So add a noise. It doesn't matter what noise really, I just need to get some more breakups, which always helps. So this plus this, make sure it's a vector. And I'm gonna add this. And remember, we don't have any extra force. This is all within one node. So yeah, we're getting some nice shapes there. And remember when we did with the volume advection, points always get stuck when they don't have a velocity field, they feel lost. And we no longer have that issue. Everything looks perfect here. I'm gonna hide the lines. Okay, so what we can do along with this is we can take these curves and add some noise to them. Attribute noise, I'm going to noise up P, point position. That's a lot. I'm going to center the noise and I'm going to make it large like that. And I'm going to move it along the y-axis. So $F multiply by divide by 50. And now my curves are changing. I'm gonna lower the change along the Y because I don't want to change that. I want them to shift between the X and Z to introduce these ripples. I think it's too fast. And the idea here is to add some more breakups because if that flow is very consistent, then this helps. That's all. If the flow is very uniform, then it's not really realistic because that doesn't happen in real life. When you see these tornadoes, if we change it over time, then it helps a bit to break up those patterns. Okay, so that's it for the tornado effects. Let's continue and see what we have to implement next to improve this. Thank you guys for watching, and see you in a bit.